7.3, solving quadratic equations by graphing. So a quadratic function is of the form y equals ax squared plus bx plus c. We're familiar with those three letters a, b, c from 7.1, identifying how they each affect our graphs. To solve a quadratic function means to find the x-intercepts, which we call the zeros, and we talked about that a little bit in the last example in 7.2, where that's what we calculated were our zeros on our calculator. A quadratic equation is of the form ax squared plus bx plus c, but equals 0 instead of y. So we're solving for those x's because our x-intercepts are our zeros, and that's when our y value equals 0. But the reason that we have our equation equal to 0. To solve a quadratic equation means to find our x-intercepts, which are called the roots. So from now on, zeros mean the same thing as roots, which mean the same thing as x-intercepts or solutions. There's quite a few terms, 4 to be exact, that you'll hear me say that all actually mean the same thing. So solving for our zeros or our roots, we're still finding our x-intercepts, so when our y value is 0. So example 1, solve for 3x squared minus 11x minus 4 equals 0 using graphing. Find the roots, it says. So this box is meant for your graph that you want to copy down that your calculator gives you. So again, I'll bring up mine so we can graph that together and know how to enter that. So I've hit my y equals button here. And I'm going to type in 3x squared minus 11x minus 4. And hit graph. Again, that's a terrible window, but that's the last window that I had back on from our last example, so we want to play with that a little bit. I know it's opening up this time, and based on what I could see, I could only see the right-hand half of my parabola because I know what it's going to look like. So now I'm going to want some negatives, and I'm going to want some negatives on my x-axis as well. So let's say negative 20. Our max will be 20. And let's do the same thing for our y's for now, just to see what that looks like, and we can always play around and change that. Okay, so it's pretty narrow now. So now let's try to shorten it, maybe negative 5 and 10 for our x's. Hit graph. Better. You could even lower it a little bit by showing more y values for a max. We want to go down to our y max, say 40. Perfect. So now we have a pretty good idea. So what I'd like you to do is to copy what you see here and on your graphing calculator into this box, just so you can have a written pictorial version of what that graph looks like. You don't have to re-enter it when you go back to look through your notes. So take this time just to copy that in here. It says find the roots, though. We want to solve. So once you've got that picture copied down, we want to calculate our roots. So either you're tracing or you're going to hit calculate. So second function trace, and we want our zeros again. So going down to 2. We need both of these. So both times we see it's crossing the x-axis, we want to solve for those. So we need to go left bound for both. So left bound of this one to the left, my y is positive. I'm on the left-hand side, which means I'm above the x-axis. I hit yes, I am. Right bound, we want to go where it's negative y. Yes. And this one says negative 0.333 repeating when my y equals 0. So that is one of them. That's one of our x-intercepts. So we want to write that down. Now we go to the other one. Second function, calculate our 0. And we need to be left bound. So now technically the left bound's underneath this point. To be left of this point, we need to be underneath as close as we can get. So there my y is negative. Yes. Right bound, my y needs to be positive above it. Yes. Calculate. So now it says my x value is 4. When it's very, very close to 0. Now, if we want to confirm or verify those points, it's just a matter of plugging them into the equation. So y equals 3 times 4 squared minus 11 times 4 minus 4 needs to equal 0. So let's change our y to be a 0. So 4 squared is 16 times 3 is 48, minus 11 times 4 is 44, subtract 4, 0 equals 48, subtract 48, which is 0. So 4 definitely works. We know that that is 1. Now same thing, we can plug that entire thing in, but negative 0.33 repeating. So I got negative 0.000004, which is basically 0. 0 equals 0. Very, very, very close just because of our rounding with our decimal places. If we use all the decimals with our repeating 3's that our calculator gives us, it'll work to 0. But based on the fact that we took only a few 3's, we got very, very close to 0. So both of those satisfy. Example 2, find the zeros for y equals x squared minus x minus 20. So there is a way algebraically we can solve these by factoring, but that's going to come up in the next section. So these ones we just want to become comfortable on our calculators by solving graphically. So with our y equals x squared minus x minus 20. And graph. So not bad window, but again, we might be changing this every time, and that's just fine. So we need to go a little bit more to the left and a little bit farther down. So let's say negative 20, negative 15 even. Y min was negative 20. We want to go farther, so let's say negative 30. And a y max of 40. Perfect. Find the zeros now. So we want to find those x-intercepts. So second function trace, we want to calculate our zeros. We need to be on the left-hand side. Yes. Right-hand side, yes. Guess. So x is negative 4 when y is 0. X equals negative 4. To the other one, second function calculate our zeros. Let's go left side of our other x-intercept, as close as we can get to the x-axis before it's positive would be here. And the right side, guess. And this x-intercept is 5. X equals negative 4 and x equals 5 would be our zeros here. Again, to confirm, just plug those points into the equation. So 0 needs to equal negative 4 squared minus negative 4 minus 20. So to 0 equal, negative 4 squared is 16, minus a negative 4 is really adding 4, subtract 20. 16 plus 4 is 20, so 0 equals 0. So that one's right. And then testing our 5. 5 squared minus 5 minus 20. 0 equals 25 minus 25, which also satisfies. So that's just a way to double check your work that your calculator gives you. Again, please be drawing in your graphing, whatever you get on your calculator, into those little boxes I've provided for each equation. Last example, example 3. Last on this page, I guess. What are the roots or our zeros or our x-intercepts for x squared minus 6x plus 9 equals 0? So x squared minus 6x plus 9 graph. Okay, we can change our window a little bit say -5. We can lower our y's. All right, so we want to find our roots. Where does my graph touch my x-axis here? Second function solve. Zeros, am I left of that point? Yes. Am I right of that point? Yes. To guess, 2.999, which is very, very close to 3. So we'd say our x-intercept is at 3, which is also our vertex here, our lowest point. X equals 3. It's 3.